If you're preparing for the GMAT, you're probably one of those people who find data insights the most challenging section. You see tables, graphs, multiple tabs, lots of text, and often you're not even sure what concept, what skill you're supposed to use. Hi, my name is Shweta Koshija. I've been preparing students for these standardized international tests GMAT, GRE, SAT for over 11 years now. Through this channel, my goal is to share my experience after having worked with thousands of students so that you don't make the same mistakes, so that you do it right. Let's get started. In this video, we're going to talk about what this section actually tests, what kind of questions it has, how you should approach them, how to practice, pace yourself, how to review if you really want to improve. Now, one important point before we begin, each of these question types has its own specific strategies, subtypes, and traps. And I teach a lot of those through actual questions in my YouTube series, Think DI, which Shweta linked up for you, because these skills are much easier to understand when you see them being used than by just seeing them in a long list of rules. Now, talking about DI, first thing you need to understand is about the section itself. It's really a section where a lot of the skills that you develop in quant and verbal come together. You need quantitative reasoning, you need verbal and logical reasoning. You may be given information verbally, numerically, in a table, in a graph, or spread across multiple sources. You need to be comfortable moving between these different forms. The type of reasoning you have to do, that also changes very quickly from question to question. One question might simply require you to retrieve a number from a table. The next one might require you to combine multiple pieces of information, make an inference based on them, or even sometimes realize that the information provided is not sufficient to answer what they're asking. Before anything, a big question I get is, when should one start preparing for DI? Now, there are two common approaches here. One approach is that you start DI relatively early so that you don't leave the entire section until the end of your prep. The other is to first build strong quant and verbal foundations and then focus heavily on DI later. My recommendation is somewhere in between. You should get exposure to DI relatively early, understand the five question types, see what they look like, see what the correct approach for all of them should be. But your heavier DI work, your timed practice, and everything, all of that makes sense once your quant and verbal foundations are strong. Because imagine your percentages are weak, your rates concept is weak, or your inference skills are weak from verbal. Then what is going to happen by just doing a huge number of DI questions? That will not solve the underlying problem. DI uses those skills, it does not replace them. Now, among the quant concepts, of course, there are many, many that you might see. Only a few of them I've listed here, and I will not deep dive here. This is not a quant lesson. For now, what I want you to understand is that these are not something completely new. It's not a new category called DI math. No, these are the same concepts, the same skills that you build while preparing for quant. It's just that the way they're presented now, the way they're asked about, that format has changed. It's just the outer cover, the envelope that has changed. The material inside is the same. Now, if I talk about the structure of this section, you have 20 questions to be done in 45 minutes. Now, that works out to an average of 2 minutes 15 seconds per question. Don't treat this as a hard deadline for every question. It's just a section average. I'll talk more about this in pacing. Now, these are the five question types that you're going to see in Data Insights. I will talk about them one by one right after this. The exact number of each question type is not fixed, but roughly speaking, you might see this split. These are approximate numbers, remember? So don't build an elaborate pacing strategy based on exactly this, right? Now, while we're at number of questions, there's some twist even there. See, a lot of DI questions require more than one response. For example, a table analysis question can have three statements that you need to answer. And say you get the first two correct and the third one wrong. Then what happens? Is it three questions? So two questions are correct, third is wrong? No, this is one table analysis question with three parts. And because your parts were not all correct, you don't get any credit for this question. There is unfortunately no partial credit. Different statements made you work differently, but overall you were only working on one single question. From that sense, if you see, DI is not just 20 questions really, if you elaborate it into the parts also that it has. Now, I'll talk about each of these question types one by one as I promised, because you absolutely need to understand the exact format of each of these, the approach you should have before you do any kind of practice, starting with data sufficiency. So, data sufficiency is different from a normal quant question because the goal is not to solve for the final answer anymore. The question is, do I have enough information given in statements to know the answer with certainty? The question is not what actually the answer is. Now, there are two broad types of DS questions, yes no type and the value type. In a yes no question, information is sufficient if it forces the answer to be yes or no. Basically, definitely yes or definitely no. If the answer could sometimes be yes, sometimes be no, then the statement is insufficient. And for a value question, if you see, any statement is sufficient if it gives you a unique value, not if it gives you a range or not if it gives you a finite list of possible values. Now, how should you approach DS? Your process should be very disciplined. First, ask yourself, what exactly do I need to know for this question to have one definite answer? Understand the requirement. Then go on to evaluate given information for sufficiency. First, you will only evaluate statement one. Is that giving me sufficient information or not? Then you forget about statement one and evaluate statement two by itself. Only if neither statement is sufficient on its own do you consider them together. Now, in all of this, proving sufficiency, insufficiency, taking values, taking test cases really helps. Now, another worthwhile discussion is about some major DS traps, places where people make mistakes. Well, one of the biggest mistakes is solving more than the question requires. Remember, in data sufficiency, your job is to determine whether the information is sufficient. It's not required for you to find the final answer. Once you have established sufficiency, just stop. Continuing will only waste your time. And another common mistake is confusing I could not solve it with the statement is insufficient. That's not the same thing. A statement may be sufficient even if you personally have not found the right way to solve it. And a major process mistake, by the way, is also mixing the two statements. When you go on to statement two after one, I've seen a lot of people, not be very careful and drag information from statement one into statement two. You cannot do that until it's the combination stage. And a specific problem in the yes no question type, students often assume that a statement is sufficient only if it gives you the answer as a definite yes. That's not true. Either a definite yes or a definite no. They're both sufficient. The key is that the answer should not vary, it should be fixed. Next question type is MSR or multi source reasoning. In this, your information is usually distributed across two or three tabs. Now, those tabs could contain passages, tables, graphs, charts. Because the amount of given information is so much more, each MSR set usually supports two to three questions. In MSR, the challenge is not simply whether you can understand each individual source, but also to build an overall picture that relates all the sources. You are here at this stage only trying to know where what information lives. You're not processing everything completely. Then you read the question. Once you know what a question requires, go back to the relative source and then read just those pieces carefully. A particular question may require you to use just one source or maybe to combine information from multiple sources. All of that can happen. In MSR now, the biggest trap is overreading, overanalyzing. You have to just know where information is located. That's not the same as fully understanding all of it upfront or just remembering the details, noting down exactly what the date was, what the name was. No, your initial goal is orientation. Detailed reading comes when the question tells you where that detail is actually needed. Next question type is table analysis. This gives you data organized in a table and asks you to make judgments based on that data. Now, how should you approach these? Your first step is orienting yourself to the given information. Read the text that comes with the table, read the table, look at your column headers, look at enough of the data to understand what each row and column represents. Then turn your attention to the actual statement or task. Ask, what do I need to check in the table to decide this? Only then decide how to use this data. Don't just jump into all the data, it'll just overwhelm you. Throughout the process, you use sorting strategically. Yes, that's a super useful feature of these tables. You can sort by any column, but don't just sort simply because the button exists. Include it in your process if it's useful to find some kind of information efficiently. Now, the traps that table analysis questions have, first is something that I've seen a lot. It's about mixing consistency with must be true. A lot of times, a question asks, tell me which out of these statements are consistent with the given information. And people start to try to answer whether that statement must be true based on the given information. It's just a word trap. Consistent simply means that this could happen based on the given information. It is consistent with it. Being inconsistent means no, 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 this cannot happen based on the given information. So it's more could be true than must be true. Such a small problem. Similarly, a lot of questions in table analysis I've seen relate with correlation. So you should understand about correlation. It does not establish causation. These are two different things. Just because there's correlation, it doesn't mean one quantity causes the other. This trap is exploited more in the verbal section. And the existence of a correlation also does not mean that there can be no exception. People look at this entire data and they're like, oh no, there was just this one place where they moved in different directions. That doesn't break correlation. You don't want perfect correlation, right? It just should be related. So read what your statement is saying. Focus on the exact words. Is it causation? Is it correlation? Is it consistency? Is it must be true? Just a few examples here, and decide what evidence actually supports the level of the claim that you're ultimately making. Then we come to graphics interpretation questions. They ask you to extract and interpret information from a visual representation. This visual could take many forms. The important skill here is learning to orient yourself quickly and understanding what it's communicating. Before solving, first step here is, as always, to understand the given information. Orient yourself with the graph like we did with the table. Now, in terms of the graph, it's the axis labels, the scales. Then you have to see what are the units that are being used throughout. Is there a legend that accompanies the graph? Are there maybe multiple series? If there's more than one axis, you have to make sure which series belongs to which axis before you start with anything. All of this should be in sync with the text that comes with it. Sometimes the graph itself does not contain all the information necessary to answer the question. A sentence above or below the visual may define a variable or provide a condition or change how you need to interpret everything. Then you go and read what is asked. You should not straight jump to reading questions as I've seen a lot of people do. Always also inspect the answer choices. The drop down options, they can tell you the level of precision that's required. If the choices are far apart, for example, estimation may be enough. You don't have to go too deep and get into your calculators. Now, among the main traps of GI, I've seen many people mess up dual axis charts. So 2 points seem to be at the same height doesn't mean they represent the same value, because they're using different axes as you see here. Also, you cannot infer any kind of measurement purely from visual appearance. A graph or a geometry diagram, that's not necessarily drawn to scale. And do not make the mistake of extending a visible trend beyond the supply data unless your question explicitly gives you a reason to do so. Next question type is two-part analysis. This can be quantitative, involving some quant concept. It can be verbal, involving conclusions, assumptions, strength and weaken, agreement, disagreement, a lot of these things, or it can combine the two also. The defining structural feature is that you have two parts to answer, two responses to select. So, first, you always read the full stem carefully. Nothing happens before that. Now, when you read the task, that is where you'll completely understand what you need to find out. Don't rely on just the column headings to tell you what the task is. Often, they're not very indicative of the exact need. Then, as you process information, you'll be able to tell whether the two parts are independent or whether solving one affects the other. If there are multiple possible answers, also simply find which pair in the choices is working for you. You don't have to find all pairs in the world. Also, stop once you've done it. Do not just keep testing every remaining option just for reassurance. That's one common efficiency trap in TPA. And another major trap is assuming that the two selections must be different. They may be the same. You know nothing about that. So don't have any kind of assumptions in your head. Now, these five formats can look extremely different, right? But there are several habits that will help you across all of them. I think this is where students often misunderstand DI. They focus so much on, the difference between DS, GI, MSR that they miss the fact that a lot of the underlying decision making is actually the same. I always talked about first understanding the given information. Now, DI often gives you a lot of it. Your job is not to process every piece at the same depth. You build a mental map first. Whether you're looking at a passage, a table, graph, whatever, understand the structure. Do good scanning. That doesn't mean you're careless. It just means you're selectively reading, and then you decide based on the task what requires further attention. Where do you need more detail? Where just knowing what is present where is enough. After understanding given information, you move on to understanding the task. Just don't let things in front of you, the amount of data, decide what you're going to do. It doesn't have to be that you use all the data that's given to you. So, first question is, what exactly am I being asked? What do I need to find? Once you know that, ask, what information is relevant to this? What can I ignore? What method then would actually establish the answer? In all of this, pay very close attention to small words. Words such as these on your screen can completely change the answer. Even logical language I've seen traps a lot of people. Not less than means greater than or equal to, not just greater than. And if I say something like if A happens, then B happens, that does not mean if B happens, then A must have happened or A happens for sure. You cannot assume all of those things. Third, make sure you're always careful about the difference between what is evident and what is just possible. This is huge. As you solve, an answer can sound perfectly reasonable and still not be supported. You have to separate this seems believable from the information given actually establishes this. DI is asking you to reason from the supplied evidence. No outside knowledge is required, no assumptions should be made, no generalizations from a sample to a larger population. No, everything should be based on exactly what you have in front of you, not on feelings. Fourth, be precise with any kind of quantitative information. Check your units. Are the graphs and the question, are they using the same units or not? Are the rates all mentioned in the same unit? Say meters per second versus kilometers per hour. They might be playing with that. Be careful before you get into calculations. Be particularly careful with dual axis charts that I mentioned before. So, how should you actually prepare now? Once you understand the different formats, the correct reasoning process for each, your practice should be progressive. You start with individual questions and focused drills. Within each question type, you work through different difficulty levels. Start with the questions that allow you to learn the process cleanly and then build toward harder questions. Make sure you're also practicing subtypes. For example, if you've become good with one kind of graph, that doesn't mean you've mastered graphics interpretation. Or if you've only practiced quantitative two-part analysis, that doesn't mean you're prepared for the non-math style TPO also. You need variety. Once you're reasonably comfortable solving individual questions, then you move to sectional practice and eventually full length mocks. But practice is also only half the process. Very important, but not enough. You need to diagnose what is going wrong whenever it does. Suppose you're consistently slow in DI. It's very easy to just say, I have a DI timing problem. Maybe. But maybe percentages are slow for you, or rates are weak, or you're struggling with inference or assumptions. Maybe you understand the reasoning perfectly, but you don't understand the question type itself, the format itself. Or maybe you're reading everything at the same depth, you're getting overwhelmed with the information. All of these are different problems. They require different solutions. Not every DI problem is fixed by doing more questions. Do not review questions, therefore, by simply writing correct or incorrect. This tells you almost nothing. The important question is, why was this wrong? What kind of mistakes did you make? Any of these could be the reason. This diagnosis matters a lot. Even time is a diagnostic. If you're taking too long, then that means there is some weakness there. So use that for constructive purposes, not to be upset about the heavy time that you're taking. Finally, let's talk about time. First thing you need to understand, accuracy comes before speed always. If you're new to DI, don't just force yourself to solve everything at exam pace. Understand the formats, make the reasoning process dependable, then build speed. If you try to become fast at a bad process, it'll just make the bad process happen faster. So that 2 minute 15-second average I talked about, just an average, it is only for reference. A direct question may take much less than that. A complicated question may take longer. So your pacing has to be elastic. And I get asked about MSR a lot when I talk about timing. Well, yes, you might spend a lot more time understanding the sources before answering the first question than for the other question types. But that orientation can help you with question 2 and 3 also know from the same set. So don't judge that initial investment purely as time spent on one question. Set your mindset that way. Now, having checkpoints is one helpful way to track your time across this section. These are not laws, these are just checkpoints to see what is taking you long. When it happens, don't ask, am I behind? Just think, why am I behind? The answer to this why is often found in lack of efficiency in your work. A huge part of becoming good at DI is learning what not to do. So don't use algebra when visual comparison is enough. Don't just keep checking answer choices because you don't feel confident. You don't have to demonstrate how much math you can do. It's about getting the answer correct and yet efficiently. The calculator works the same way. It's just a tool. Use it when it saves you time. Don't treat every numerical question as a calculator question. So before you calculate, ask whether you can estimate or reason directionally. Can I tell it's supposed to be greater than this or less than that, for example? So correct question is, what method is the most efficient here? Don't just scramble and somehow find the answer. And even when you're finding it, use as much precision as the answer choices require. Finally, one big point from pacing psychology. Be careful about sunk cost. Just because you've spent 3 minutes on a question does not mean another minute is worth spending. That previous time is gone. The decision you have to make now is the next minute more valuable on this question or somewhere else in the section? Now we are at the end. If you remember nothing else from this video, remember that DI is not a completely separate universe from Quant and Verbal. It's where a lot of those skills come together, and then you're asked to use them while managing information efficiently. As we walk through actual DI questions in Think DI with Shweta, you'll see these principles come up again and again in real situations. And that is where the deeper strategy becomes much more concrete. Till then, happy learning. Let's do it right.